Physics chapter 17 video 7 theory. Now we are going to look at vector diagrams. So a vector diagram is a diagram which we can use to find out the resultant force or resultant velocity of an object when two or more forces are acting on it. So here we are looking at the change in velocity initially and after some time. Now, if you look at the first diagram here, you will see that the object has moved from point A to point B, and as you can see, there is a change in the direction. So that the direction has changed. So now, as you can see from the length of the arrow, nothing has happened to the speed. So we know that when in circular motion, when an object is moving, even though it is accelerating towards the center, it can have the same speed. So that is exactly what has happened here. But because the velocity has changed, we can use a vector diagram to figure out how much the velocity has changed. But please don't confuse this, because this does not actually mean that there is a numerical change in the value, right? But the velocity is changing. Remember, it is the velocity. We are not talking about the speed. If the speed changes, then it is a numerical value. Here the velocity is changing because its direction is changing. Now, according to Newtonian law, once again, if you look at this part, according to Newtonian second law, F equals ma. So the acceleration of the object is in the same direction as the centripetal force. So the acceleration is towards the center of the circle, or rather because if there is a velocity changing, if the velocity is changing, that is changing because of the acceleration. So if the acceleration is towards the center, then that means the velocity is changing towards the center. So that is the reason why you will get the vector representing the change in velocity to the center. Right? So I hope you understood that. Don't confuse it, don't make it more confusing. Just remember these factors. The centripetal force always acts towards the center. As a result, velocity change is also towards the center. So the velocity change is because of acceleration. Acceleration is also towards the center. Right? It is all directed towards the center. Now, acceleration is the rate of change of velocity. So for this particular situation, we can take it as delta V over delta T. Right? Delta V over delta T. Now, that relationship you must understand. Now, when we go to the next level, we start thinking, all right, there is an acceleration, but why won't it change the speed? Why won't it change the speed? Because here we were talking about delta V, right? We have now understood that only the direction is changing, but why won't it affect the speed? So let's try to figure out. Now we establish that the centripetal force is always towards the center. So if there is a force acting in some direction, there has to be a component in another direction to have any change to be done. For example, if we are to look at this particular instance, now uh, there is let's say this circular part is there. An object is moving in this position. In this position, an object is moving. So if this object is going to have a velocity in this direction, but if the centripetal force would be in the center, towards the center, but this object at this particular moment, it is moving in this direction. So now what does it tell us? The angle between the direction in which the object is moving and the direction in which the object is accelerating is 90 degrees. Now, what is the component of this force in this direction? F cos 90. If you use the calculator, you will realize it is 0. So because it is 0, we will not be having any acceleration. Because it is 0, there won't be any acceleration in this direction. If there is no acceleration, there is no change in velocity in that particular direction. I hope you understood that. Let's write down a note. Vector diagrams. To figure out the change in velocity in an object traveling at steady speed around a circle, change in velocity moving at steady speed around a circle, we can draw a vector diagram. Pause the video and draw figure 17.9. Now, I hope you have finished drawing it. Now write down. According to the vector diagram, the change in velocity delta v, is always at right angles to the velocity at the initial point and is directed towards the center of the circle. The acceleration is the rate of change of velocity, comma, then write the equation A equals delta V over delta T. This acceleration should be in the direction of the change in velocity. Leave a line, put a star and write down. According to F equals ma, the acceleration is in the same direction as the force. Leave a line and write. However, the speed of the object remains constant because the centripetal force has no component, within brackets write has 0 component. In the direction in which the object is already traveling. Leave a line and write, because f cos 90 equals 0. Thus, the object will pull, the object will be pulled towards the center without changing its speed. Now, another way to describe this is actually using work done. Now, work done is equal to force multiplied by distance moved in the direction of the force. Now, because now here the distance moved by the object now is 0, because it does not come towards the center. There is a force, but in the direction of the direction where the force is acting, it does not go in that direction. So as a result, the work done is 0. If the work done is 0, the kinetic energy must be the same, so the speed should be unchanged. Write that down as well. Using the concept of work done, within brackets, right, work done equals force into distance moved by the object in the direction of the force. We can describe why the speed is unchanged. The object does not move towards the center, but rather travels around the circle, maintaining the radius. Hence, there is no work done. As a result, kinetic energy must remain constant and the speed would be unchanged. Right. Now I want you to pause the video and answer question number 12. After you have answered, then play this video again, then the answer would be discussed. Right. So I hope that you have done the question. Now let's discuss that. An object follows a circular path at a steady speed. An object follows a circular path at steady speed. Describe how each of the following quantities changes as it follows this path. Right? So the main thing is reading the question properly. So you have to be very, very cautious. You have to read it very carefully and you have to take all the details into your head. Speed, velocity, kinetic energy, momentum, centripetal force, centripetal acceleration. Refer to both magnitude and direction as appropriate. So you have to be very cautious and you need to know what each and everything is. Right. Now let's try to take the speed. Now speed, is it a vector quantity or a scalar quantity? It is a scalar quantity. Speed, what happens to the speed of the object? Nothing happens to the speed of the object. It does not change because it is a scalar quantity. Speed continues to be the same. However, velocity is a vector quantity. Because the direction is changing, the velocity changes. Because there is an acceleration towards the center. Centripetal force is accelerating the object. But towards the center, therefore the velocity changes. Then momentum. Momentum has a constant magnitude because the numerical value is the same, but its direction changes. Then centripetal force. Once again, centripetal force, it has to have a direction, but in this particular situation its magnitude remains the same, but its direction always changes. Then centripetal acceleration. Once again, acceleration is also in a direction. It is a vector quantity. As a result, it also changes the same way as the centripetal force. So I hope you have written down all of those answers. If you have any questions, please raise them. Thank you.